Hey everybody, we're live and in stereo. So we're now going to look into chapter number 3, MCQs, the 2024 set, which is the redox set. It's just a 15-minute quick class because I think there are 9 and 10 MCQs. Let's do it together for the first time, obviously. And if your concepts are clear, I've taught everything in the live class. So you don't need to worry about literally anything. Everything is done. Now, when you start solving MCQs, it should be a piece of cake. I always say A-level MCQs are far more easier than any other level MCQs because if your concepts are clear, it should be a piece of cake. You know, it's straightforward answers. Let me just look into it. So he's saying in alkaline solution, MnO4 minus ions oxidizes SO3 2 minus ions to SO4 2 minus ions. The MnO4 minus ions are reduced to MnO2. What is the ratio of the two ions in the balanced chemical equation? Again, what's happening? MnO4 minus ions are going into MnO2. MnO4 minus going into MnO2, and you have SO3 2 minus going into SO4. We know how to balance it. How do we balance it? Well, we look at the atoms first. Except for hydrogen and oxygens, we look at the atoms. They should be balanced. Mn, balanced with Mn, good stuff. 4 oxygens here, 2 here. So we add H2Os to balance the oxygen on the deficient side, right? So we have 4 here and 2 here. You need 2 more O's on the right. We write 2 H2Os. And you know why you do that? Because basically the hydrogen ions pluck the O's and give you H2Os. And therefore, now you need to balance out the H's. You have 2 times 2, 4 H's on the right. You have no on the left. So you balance out the H's with the hydrogen ions, and then we just balance the charges. Let's balance the charge. You have -1 charge here and 4 positives here on the left, and you have 0 charge on the right. So the overall charge on the left is not 0, obviously. It's +3. Why +3? Because you have +1, +1, +1, +1, 4 times +1s and 1 -1. So +4, -1, +3, and on the right hand side you have 0 charge, right? So how do you make the charges equal? Well, we are going to add 3 electrons here. 3 electrons, balance it out. We write the electrons on the more positive side. Done. This equation is balanced, we know. Next, SO3 2 minus to SO4 2 minus. Then, how do you do this stuff? Well, again, write the H2Os on the more deficient side. Here you have 3 O's, here you have 4 O's, so add H2O to balance out the O. Now you have 4 O's. Now in order to balance out the H's, we write the hydrogen ions, and we're on the deficient side. So here you have 2 H's here, write the hydrogens on the deficient side, where is right here. So 2 hydrogens. Then balance out the charges. You have -2 overall charge here, you have -2 +2, 0 charge here. So what? -2 charge here, 0 charge here. How do you make -2 and 0 equal? Well, I'm going to add 2 electrons here. Why? If I add 2 electrons here, that's going to give you -2 here. So that the equations are balanced. Now you need to write the full equation for it. How do you write the full equation? Well, pretty simple. Electrons lost must be equal to electrons gained. So the gained electrons are 3, lost are 2. What do? We multiply them in order to make the electrons equal. So the 2 is being lost. I'm going to multiply this with 2, and whatever is written above, I'll multiply it with 3 here. Why 3 here? It's basically LCM. 3 and 2 must be equal. Electron lost and gain must be equal. How do you make them equal? You can take an LCM, 3, 2. What's the LCM? 2 ones are 3 as it is, 2 ones are 3 ones are. So the LCM is 6. And therefore, what should I multiply 3 with to get 6? With 2. What should I multiply 2 with to get 6? With 3, obviously. Or you could just use a shortcut. Whatever is written here, multiply it there. Whatever is written here, multiply it here, right? And we've done so many examples like this in class, right? Now, once you add them all together, I don't even need to do anything. He's saying what's the ratio in the balanced equation. Once you multiply them, they're already balanced, right? So what's the ratio? Well, you have how many MnO4 minus? You have 2 MnO4 minus, and therefore B is wrong, C is wrong, D is wrong, A is the correct option. Why? See, that's why A-level is so crystal clear, because if your concepts are clear, the answer is right in front of your eyes. See, you have 2 MnO4 minus and 2 MnO4 minus ions, and how many SO3 2 minus do you have? 3 multiplied by SO3 2 minus 3. So you have 3 SO3 minus ions and 2 MnO4 minus ion. 2 MnO4 minus ion for 3 SO3 2 minus ion. Easy peasy, lemons hoisy. Done. And obviously it's an alkaline solution. We don't even need to look into that, how to balance alkaline solutions. We don't even have to look into that. That's it. Done. Next, equations for some reactions of hydrogen peroxide are given. In which reaction is hydrogen peroxide acting as a reducing agent? What does a reducing agent do? It reduces the other substance, right? It reduces the other substance by oxidizing itself, but reduces the other substance, right? So you have to see whether the other substance, this is hydrogen peroxide, H2O2, is the other substance being reduced or oxidized? Pretty simple. See, Fe is 2 plus here, and here it's 3 plus, right? So Fe went from +2 to +3. Is it being reduced or oxidized? Sir, Fe is being oxidized. So here H2O2 is acting as an oxidizing agent, not as a reducing agent, right? Because if it were a reducing agent, Fe3 plus should have gone into Fe2 plus. Here 2 plus is going into 3 plus. Fe is being oxidized. So H2O2 is oxidizing Fe. Here, look at this. Look at this. You don't have to look into anything. It's so crystal clear in front of you. Look at H2O2. What is it doing? You have MnO4 minus here and you have Mn2 plus here. What's happening? What's happening to MnO4 minus? You can calculate the oxidation state out. Mn is X, oxygen is minus 2, times it by 4. Overall oxidation state is minus 1. X minus 8 equals minus 1. X equals plus 7. So Mn is plus 7 in MnO4 minus. And here how much is Mn? Mn is plus 2. So you are going from plus 7 to plus 2. What is happening to Mn? Sir, MnO4 is being reduced. So yes, H2O2 is in fact acting as a reducing agent. Because what is it doing? It is reducing MnO4 minus. How is it reducing it? Well, you can see it. It went from an oxidation state of plus 7 in MnO4 minus, and it went from plus 7 to plus 2. Pretty simple, logical, easy. Again, Fe3 plus is right here, and it goes from Fe3 plus to Fe2 plus. What's happening? Is it being reduced or oxidized? These are the tricks that you need in MCQs. Your concepts are clear. In MCQs, you are tuck, khatam. Fe3 plus is going into Fe2 plus. Is it being reduced or oxidized? Obviously, you've reduced iron. So yes, here H2O2 is also acting as a reducer. Because obviously, if this is being reduced, something is reducing it. H2O2 is reducing it. H2O2 is reducing this fella. Here H2O2 is oxidizing this fella. So 2 and 3. Boom. This is the correct option. Easy. Oh, so simple. Next. The equation for the reaction of aqueous thiosulfate ions and aqueous dioxovanadium ions are shown. Which row shows the correct statements about the equation for the reaction? Break it down. I've taught you guys how to make two half equations. So S2O2 S2O3 2 minus is going into S4O6 2 minus, and VO2 plus is going into VO2 plus, right? The H plus ions and H2O would automatically come here when we start balancing it, right? We know that. We've studied it. So S2, you have 2 S2O3 2 minus going into what? It's going into S4O6 2 minus, right? That's the first half equation that I need to balance. VO2 plus going into VO2 plus, right? Let's start balancing it. First of all, balance out the atoms. You have 4 and except for O's and H's. So 4S here and 4S here. It's already balanced. Good stuff. Now start balancing the O's, right? Let's balance the O's. You have 2 times 3. You have 3 O's on the left and 6, you have 2 times 3, 6 O's on the left and 6 O's on the right. The O's are balanced. Next, balance out the H's, right? You don't need any H's. Why? Because the O's are already balanced. I don't even care about the H's, right? Then what am I going to do? I just need to balance the charges. You have how many charges here? You have 4 minus charge on the left total. Why? Because it's 2 minus. You have 2 of 2 minuses. So minus 4 charge on the left. How much charge do you have on the right? Minus 2. How do you make minus 4 equal to minus 2? Well, you add electrons on the more positive sides. I'm going to add 2 electrons here. Because once I add 2 electrons here, you're going to have a total charge of minus 4. So the first equation is balanced. Easy, right? Simple steps. Next, VO2 plus VO2 plus, right? VO2 plus VO2 plus, right? Now, how do I do this? First of all, balance all the atoms except for H's and O's. I've balanced it. VV already balanced. Balance out the oxygens with H2O. You have 2 O's on the left, 1 O on the right. So how do you balance the O's? You add 1 more O here. How? In the form of H2O. And we've already studied the logic behind why we do that. Now, this is not time for logics. If you want to know why are we writing H2O, I'm the only teacher in Pakistan. I am telling you this because I've seen 9 teachers' videos that why do we do this? Nobody's teaching this. Why are we actually doing this? I've taught you guys why we do this. To pluck the O's, right? Remember that? So we don't care about the Y's for now. So khair, आगे बढ़ें. So you've balanced the O's. Now balance the H's with the hydrogen ions. So you have 2 H's on the left. Balance it with the hydrogen ion by writing the hydrogens on the more deficient side. Then balance out the charges. How many charges do you have? You have a 1 plus charge and 2 plus charges. So in total you have plus 3 charge on the left, and in total you have a plus 2 charge on the right, because H2 is a compound. No charge, no overall charge. How do you make plus 3 equal to plus 2? Add an electron on the more positive side. So this will also become plus 2. Done. Now it's these both equations are balanced. Let's now add these 2 equations. How? Well, the electrons gained and lost must be equal. So if 2 electrons are being lost, 2 must be gained. Whatever electron is written at the bottom, you can even multiply it at top, multiply this by 1, and whatever is written at the top, you multiply it at the bottom, because effectively you're making the electrons equal. That's it, right? So once I multiplied these fellas, I realized what's happening. He's saying that Change in oxidation number of vanadium. I should have also read the question. He's saying change in oxidation number of vanadium. I have to just look into the oxidation number of vanadium. Let's calculate it, right? So oxygen is -2 always, but let's calculate vanadium. Let's do our working. How do you calculate vanadium right here? Well, I don't know what vanadium is. I'll call it X. Oxygen is always -2 in this case, multiplied by 2 because you have two oxygens. Add them together. The overall oxidation state of any ion is its charge. So this is +1. X minus 4 equals +1. X equals +5. So you're effectively going from +5 to what? Again, oxygen is -2. Vanadium is X. I don't know. But oxygen is -2. Overall oxidation state of any ion is its charge, which is +2 right here. X equals -2 goes there. X equals +2, +2. That's +4. So you went from +5 to +4. And once you do that, the oxidation number, automatically A is wrong and D is wrong. You went from +5 to +4. Great. Now, comparison of X, Y, and Z. To figure out X, Y, and Z, I needed these two equations. So let's do this. Let's add them together now. So you have 2S2O3 2 minus, and then add this left-hand side. You have how many VO2 pluses? 2 VO2 plus. Sir, why 2? Why not 1? I've multiplied the 2 with the entire equation. Plus 4 hydrogen ions gives me 2 VO2 plus 2 H2O plus S4O6 2 minus. I'm just adding the left hand side and the right hand side. This is the right hand side and that's the left hand side. I'm just adding the left and right. Electrons lost gained equal. Done. Thak, thak. Khatam. I finally understand stuff. Awesome, Hashim. I'm glad you do. I'm glad you do. We've already done this and I'm glad you do. Now he's saying, tell me this. X and Z are the same. What is X? X is VO2 plus and Z is VO2 plus. So X and Z are the same value. Yes, they are the same value. Every option says it. I just have to look at option B and C now. So they are the same value. They are. And they are half the value of Y or quarter the value of Y. Tell me. Y is hydrogen ions. So tell me this. Is it half the value of Y or quarter? Quarter means 4 divided by 4. That's quarter. So is it half or quarter the value of Y? Value of Y is this. Value of X is this. Is X half of Y or quarter of Y? Come on. I think if I tell this to my little 6-year-old sister, she's also going to tell me that X is half of Y. Isn't that true? X is half of Y. Agreed. It's half, not quarter. If it was quarter, then X would have been 1. Right? So X is half of Y and C is the correct option. That's why I tell you guys concepts, and slowly and gradually, once you are starting with these MCQs, you'll realize this, that Sir Suleiman was right all along. The way he taught us the concepts were so important that now these things are a piece of cake for me. I can do it with my eyes closed. I promise to you guys, I've never done these MCQs before. I'm doing it for the first time with you guys. And I'm breezing through them. My concepts, it's concepts, game of concepts. And I've taught you the same concepts I know myself. So yeah, it's a piece of cake. Khair. The name chlorate is used for an anion, a negative ion, of chlorine and oxygen only. In a molecule of ICl, the iodine atom has an oxidation number of X and the chlorine atom has an oxidation number of Y. When ICl is added to H2O, iodine is reduced. Okay, good stuff. Now, he's even told you this, that iodine is reduced. You're not expected to know the oxidation number of I and Cl. Not right now at this stage. But he's given you information. He's saying iodine has been reduced. What this means is, see, in this particular molecule, either this would be +1 and this would be -1, or this would be -1 and this would be +1. I know that I2 here is in its pure elemental state, so it's 0. Now, if you guys look at the I, he's saying it's being reduced. What that means is, did it go from +1 to 0 or -1 to 0? If it were -1, it would have been called that iodine is oxidized. Then I would say that I is -1 and this is +1. And if he's telling me that it's reduced, that means what? That it was +1 and it went from 0. Yeah, there are only two possibilities. It's either +1 and -1, or this is -1 and this is +1. And I understood that he told me it's reduced, which means it must be +1 and it went from +1 to 0. So this is the correct bit. This is +1. This is +1 and this would be -1. And one more fun fact. I think I've also taught you guys this in the live classes. I've taught you guys this even in the live classes, that see, it all has to do with electronegativity. Which one is more electronegative? Is chlorine more electronegative or is iodine more electronegative, right? Obviously, chlorine is more electronegative. It's at the top. compared to iodine. So the one that's more electronegative, that should have the negative oxidation number. Just like, hydrogen is always +1. Hydrogen is always +1 because out of these two, chlorine is more electronegative in this case. But remember when I taught you guys hydrogen being bonded to sodium. In this case, between these two, hydrogen is more electronegative than sodium. Therefore, this was -1 and this was +1. So it all has to do even with electronegativity. Let's suppose the examiner did not tell us this, although by law, by book, the examiner is bound to tell us this because we don't need to rote learn these. But if you still know the concepts, which I know, even if he did not tell me this, I'd safely assume that that's the reality behind it. But he'll always tell it to you. Which statement about the value of x or y is correct? Okay. Let's talk about x or y. What is he calling x? He's saying that the iodine has an oxidation number of x. So he's calling this x, and chlorine has an oxidation number of y in ICl. So +1 is x and -1 is this. Now I think x is the same as the oxidation number of Cl in the chlorate ion formed when Cl2 is added to cold NaOH. Please, I have not taught you guys this reaction yet. You are going to learn this in chapter 4. That's why I said chapter 4 is very important, but I'll just quickly write the equations for you. So if you add chlorine to cold NaOH, please, I'm going to teach it in chapter 4 in obviously the group 17. When we study group 17, I'm going to teach it to you. We are done with group 2. Tomorrow when we study group 17, you're going to come across this equation. But if it's added to cold NaOH, these are the reactions. This is what forms. Why does this form? For now, it's not my concern. Yeah, but this is what forms. And if you add it to hot NaOH, I'm just writing the equations for you guys because you've not studied these yet. And you learn them. I'll make sure that you know them later on. Don't be, dwindled or swindled by these equations. I just want you guys to calculate the oxidation number here. In cold, what's the oxidation number of Cl? What's the oxidation number of Cl? In cold, shabash. What's the oxidation number of Cl in these two? In cold and hot. Please, I have not taught this. Don't ask me how did you come up with this equation. I have not taught this. I've just written the equation which the examiner has said. Cl2 reacted with cold NaOH. Cl2 reacted with hot. I'll teach this tomorrow, inshallah. Not today. Just tell me the oxidation number. Be quick. This is what? +1, if I'm not wrong. If you can't do that, this is ClO minus chlorate ion, right? If you want to calculate it, this is x. Oxygen is -2 equals to -1. X equals +1. Right? And if you want to calculate this fella right here, sodium is, I don't even want to look at sodium, it is ClO3 minus ion, right? So chlorine is x, I don't know, oxygen is always -2, right? So -2 times 3, add them together, overall oxidation number is -1, x minus 6 equals -1. We've done so much practice of this, so you guys should be able to calculate this very easily. This is +5 and +1 here. So he's saying that x has the same oxidation number of Cl in the chlorate ion when it's added to cold. Is that true? See, x is +1. X is definitely +1 right here. And in chlorate, in cold, is it also +1? In cold, is it also +1? Absolutely it is. When you added chlorine to cold NaOH, it ended up with +1. So that's true. With hot, it's +5. See, in cold, it is in fact +1. See, saying x is the same oxidation number of Cl when it is added to hot. No, in hot, it's going to be Cl is going to be +5. I even wrote it for you. Y is the same oxidation number. Nah, done, dusted. They're not. See, Y is the same oxidation number of Cl in the chlorate ion when Cl2 is added to cold. No, Y is not. It's Y is -1. And this is +1. Y is -1 and this is +5. So both are wrong. Right? A is the correct option. Pretty easy. Next, phosphorus reacts with concentrated sulfuric acid to produce phosphoric acid, sulfur dioxide, and water. A, B, C, D are the whole numbers of the equation. And he's saying balance out A, B, C, D. Can you guys do this? Can you guys do this? I'm going to use my oxidation numbers. I don't want to break it into half equations. If you want, you can even break it. H2SO4 going into SO2 and P going into H3PO4. This water is obviously going to come automatically when you start balancing. But I'm going to use the oxidation number here. Because remember, you can always use that shortcut only. Remember the oxidation number shortcut that I taught you? You can only use it if a full equation is given to you guys. And in this case, yes, the full ionic equation is given to me in fact, right? It's a full equation, I'll call this, right? So only if a full equation is given to you, you can use the shortcut. What was the shortcut? What's the oxidation number of sulfur here? It's +6. I hope you can calculate it. In sulfate, sulfur is +6. I know I don't want to go into the detail of how it is this +6 and how this is +4. You guys should know this at this point. H2SO4, how is sulfur +6? It's the sulfate ion. Please don't ask me how you can calculate this. It is like a piece of cake for now. This is -2. -2 is oxygen, times it by 4, you have 4 O's. Add them together, overall oxidation state is -2. X minus 8 equals -2. X equals +6. -8 is gone there. It becomes +8. +8 minus 2 is +6. Done. And similarly here, how is it +4? Oh my god. Kill me. This is X. I don't know. Oxygen is always -2. And when you want to calculate the overall oxidation state of any compound, take all the oxygen. So -2 is oxygen, but times it by 2. So 2 times -2. Add them together. Overall oxidation number of any compound is 0. X minus 4 equals 0. X equals +4. That's how I came up with +4 and +6. At this point, you should be pretty quick at it. Here, phosphorus here is 0. And here phosphorus is in the phosphate ion, PO4 3 minus ion, right? H3PO4 कैसे बना है? PO4 3 minus, here has a charge of plus, PO4 is 3 minus, that's how you got H3PO4, cross multiply. So calculate PO4P for me, please. I think it's +5 if I'm not wrong. If I'm not wrong, you guys can calculate it, yaar. Phosphorus is X, oxygen is -2, times it by 4, you have 4 O's, add them together, overall oxidation state of any ion is its charge, X minus 8 equals -3, X equals +5, come on, I shouldn't be doing this at this point, so this is +5. Now, you went from 0 to +5, there's a loss of 5 electrons, done, and you went from +6 to +4, there's a gain of 2 electrons, right, because there's a decrease in oxidation number by 2, and there's an increase in oxidation number by 5. So gain of 2 electrons and loss of 5 electrons. How do you make them equal? Gain must be equal to loss. So multiply this with 5 and multiply this with 2, because gain must be equal to loss, right? So whatever is written here, multiply that here. Whatever is written here, multiply this here. And once you multiply this by 5, obviously this 5 should drop down here. This 5 should drop down here. And what did you multiply 2 with? This fella. So this 2 should drop down here. This 2 should drop down here. Please add A, B, C, D. So 5 plus 2 plus 2, that's what? 7, 7 plus 2, 9, 9 plus 5, 14. Should I go for B? Yes, no. Should I go for B? This is the typical mistake students will make. Sir, pata nahi kya ho gaya? Should I go for B? 14. 5 plus 2 plus 2 plus 5. Yes, no, absolutely not. You've forgotten about E. E, at the end, you also have to balance E out. How do I balance E out? Pretty simple. See, I have how many O's? Let's look into H's, because H's is easy. See, how many H's do you have on the left? 10. 5 times 2. You have 10 H's on the left. And how many H's do you have on the right? 2 times 3. You already have 6 H's on the right. You need how much more? You already have 6 on the right. How many more do I need? For E, how many more do I need? I need 10 in total. 6 are already here. I've already balanced 6 H's out. I need 4 more. So what should I multiply 2 with to get 4? Hydrogen is 2. What should I multiply to get 4? 2. So E is also 2. So what do you get? Now sum it up. 5 plus 2 plus 2, that's 9. 9 plus 5, that's what? 14. 14 plus 2, that's 7. 14 plus 2, that's 16. D. That's so easy. I can't even fathom how easy these are. It's a walk in the park, and so should it be a walk in the park for you guys. Yes. Pretty logical, huh? Pretty logical. Everybody, chlorine gas is reacted with cold aqueous sodium hydroxide. I have not taught you guys this. I'll write it here. That's why chapter 4 was important. लेकिन खैर अब कर ही रहे हैं तो कर लें. ये equation लिख लें. It's with cold. This happens with cold. Why does this happen? Story for tomorrow. For now, just believe me when I say this is the equation with cold. But I hope that you guys can calculate the oxidation numbers for it. What's the oxidation number? Chlorine has an oxidation number 0. This is -1. This is +1. We literally calculated it above. Chlorine is both oxidized and reduced. Is it? Chlorine went from 0 to -1 and chlorine went from 0 to +1. Is it both being reduced and oxidized? Yes, it's reduced here. It's oxidized here. What is this type of reaction called, by the way? Chlorine being both reduced and oxidized. A redox reaction in which a species in a single element is both being oxidized and reduced. What's that called? Shabash. That's called a disproportionation reaction. So chlorine is in fact being both reduced and oxidized. Next. In which reaction does the oxidation number of chlorine change by the largest amount? What's the oxidation number of chlorine here? If I'm not wrong, it's +5. Sir, how are you calculating +5? See, it's the chlorate ion, ClO3 minus ion. We've done this a bajillion times. This is X. Oxygen is always -2. But if you want to do my working, -2 times 3 plus add them together equals -1. X minus 6 equals -1. X equals +5. At this point, we've done it so many times that chlorate ClO3 minus thak +5. Khatam. And this is -1, obviously, is group 7, -1, ionic compound. Done. Let's look into ClO minus. ClO minus. Again, this should be +1. To be very honest, at this point, it should be in your brains. But if it's not for some reason, this is X. Oxygen is always -2, and you have 1 O. So I'll just add it here. Equals to -1 overall charge. This will equal to +1. Done. So it's +1. Pretty simple. So it's +1 here, and this is -1 here, and here ClO2 minus. ClO2 minus. I should reckon that it's +3 here. It's like this is X, this is -2, -2 times 4, -2 times 2, that's -4, equals -1, X equals -4 goes there, +3. See, when I tell you guys it's a walk in the park, I tell you guys it's a walk in the park. Cl2, 0, this is -1, this is +1, already calculated it here as part of ClO, right here. So this ClO is my +1, this should also be +1, done. For D, this is 0, this is already calculated, that ClO2 is +3, that's -1, that's what, +3. So where is the largest change? Right here. +5 say -1. There's a change of 6, a delta of 6. In no other place is there a delta of 6. No other place. This is +3, 0, and this is +3, -1. There's no delta of change of 6. So A should be the correct option. Next. कितने रह गए यार? Oh my god. Okay, 12 more stuff to go. ये मैं बाद में complete कर लूँ. I'll upload the recording because the mehman are waiting. So चलो let's just look into this. HNO2 undergoes a disproportionation reaction to give you HNO3 and NO2. Okay, HNO2 gives me what? HNO3. That's the first half equation, and the second half equation is that HNO2 gives me NO. Balance it out, shabash. First of all, balance all the atoms except for O's and H's, N balanced. Then balance out the O's on the more deficient side. So here you have 3 O's, here 2 O's. Add one more O in the form of H2O. Done. Then balance out the hydrogens. Well, you have one hydrogen here. You have 2 extra hydrogens on the left. So add it on the more deficient side by writing 2 hydrogen ions. Done. Then balance out the charges. You have 0 charge on the left. You have a +2 charge on the right. So add 2 electrons here to balance this out. Khatam. Agla. Shabash. HNO2 and NO. Balance out all the atoms except for H's and O's, which is N and N are balanced. Next is balance out the O's on the more deficient side, obviously. So 2 O's on the left, but 1 on the right. So balance it out with the H2O. Then you have 2 H's on the left. You only have, how many H's do you have? 2 H's on the left, 2 H's on the right and 1 on the left. So I just need one more H. H plus ion. Then balance out the electrons. Well, you have one plus charge on the left side and there's 0 on the right. So add an electron on the more positive side. Done. Now 2 electrons lost must be equal to 2 electrons gained. So multiply this entire equation by 2. And however many electrons are here, multiply it by 1. Or you do not need to multiply it by 1, but that's it. Then you just need to balance it out. So how many HNO2s do you have? Sir, 1 HNO2 here and 2 HNO2s here. So in total you have 3 HNO2s. Done. How many H2Os do you have? Sir, this H2O cuts out with these 2 H2Os. So on the right hand side, you only have 1 H2O. In the end, you could add the left and right and then simplify it at the end. I'm simplifying it directly. See, 1 H2O on the left and 2 on the right. So H2O cuts out with one of the H2O, you're left with 1, right? Then the hydrogen ions. You had 1 hydrogen ion on the left and you have, you don't have 1, you have 2. So 2 hydrogen ions on the left and 2 on the right. So these 2 hydrogen ions cuts out with these 2 hydrogen ions. 2 electrons on the right, 2 electrons on the left. This is not 1e, it's also being multiplied by 2. So everything on the left has been added. On the right, let's write the HNO3 for me, please. Plus, how many NOs do you have? 2 times NO. 2 NO. Plus. Done. So 3, 1. This should be it. 3, 1, and 2. So, and that's the idea. See, he's saying W are the modes of HNO2. So W are 3. See, A is wrong, C is wrong, D is wrong, B is the correct option. That's how beautiful A levels is. Do you know what A levels do to you guys? It does the complete opposite of O levels. Do you know what happens in O levels? A level MCQs are considered difficult because students tend to rote learn them and students tend to just tukkafy them. Do you know the tukka that teachers teach you in O levels? Do you know the tukka that teachers teach you? The satti? The mini guessing trick that teachers teach you? Even in A levels, you will see these pathetic teachers telling you, sir, I'm sorry guys, I'm sorry that I say this about my peers or my colleagues, but they should work on their skills. They are taking money for this. If you're taking money for something, you should be loyal with it. If a teacher is watching my video, work on your craft, and it's good. It's a first step in watching this video or watching any other video to polish your craft. You are a good teacher to be continuously working for your students. See, in A levels and even in O levels, teachers tell you, the answer should be, if W is these, see, these two are already different. So if these two are the same, then the answer should be between C and pathetic BS. That's what does not work in A levels. That's the beauty. It's pure concepts. Do you know why the examiner has given you a 5-5 here? Because the examiner knows if you don't know the answer to it, you'll probably go for C or D, because you'll say, hey, eeny, meeny, miny, mo, these two are different. I think the examiner were to ask me in these two. That's what you will do. The A level people know this psychology. It's all psychology. Khair, ICl is made with chlorine and iodine react together. ICl reacts with water. Which row is correct? What is the oxidation number of I? Yeah, come on. What is the oxidation number of I in ICl? Again, we know that. Sir Tulman has taught us electronegativity. This is more This can either be +1 and this is -1. This can also be -1 and +1, right? But Sir Suleiman has taught you guys this stuff, which is what? Which is that this is more electronegative. So minus should lie here. This is +1. This should be -1. Done. So it's +1. These two are cancelled. Done. Reaction occurring with ICl reacts with, when ICl reacts with H2O. The iodine atoms are, or let's look at what's being oxidized. And see, this is the iodate ion. Which iodate ion? Sir, I is X. Oxygen is always -2, but when I'm using the overall oxidation state of any compound, -2 into 3, add them together equals -1. X minus 6 equals -1. X equals +5. So the iodate ion right here, the I in iodate ion is +5. Done? Achha, and this I2 is pure elemental state 0. My question to you guys is one question. Is the O having the oxidation number of -2 or -6? -2 or -6? Please, everybody, I want everybody to answer this. Is O having an oxidation number of -2 or -6? Please, I've worked so much on this. Don't disappoint me, please. Even if you do, it's fine. Then you have to watch the entire redox videos all over again. Shabash, -2 or -, everybody needs to answer this, not just Noor. Please, only Noor is answering. Come on. -2 or -6? Jage mein so gaye. -2, -6. It's -2, please, not -6. We are considering every single O in this when I talk about the overall oxidation number. Remember this, it's -2, not -6. I'm just using it for the calculation purpose. We've looked into it in a lot of detail. This is -1 here. Okay, khair. The iodine atoms are oxidized to form I2. Are they oxidized? You went from +1 to 0. They are being reduced to form I2. So B should be the correct option. And why is B correct? The iodine atoms are oxidized to form HiO3. Yes, they are oxidized. You went from +1 to +5 here. Achha, yeah. And can I call this a disproportionation reaction? Yes, it is, because the element in the single species is being oxidized and reduced, both. And it's a redox reaction. Right? One of the reactions is the rechargeable lead acid battery shown. See, these are practical examples. This is how your car lead acid batteries work, literally. That's it. If somebody were to ask you how do car lead batteries work, these questions are so important. It'll help you. It'll tell you this is how they work. Lead has an oxidation state of 0. This is +4 here. Sir, how do I know it's +4? See, PbO2, come on. This is -2. Pb is X, I don't know. Oxygen is -2. Times it by 2. You have 2 O's. Add them together. Overall oxidation state of any compound is 0. X minus 4 equals 0. X equals +4. This is how I do it. Math. Pretty easy. Here, lead is what? Because the question is about lead, so I'm just looking at lead. Lead here is +2. Why? Because it's Pb sulfate. Sulfate is 2-. I know that. So this should be +2. And therefore the charge on the ion is the same as the oxidation number. So that's it. Lead here, on the left hand side, lead is 0 and +4. And on the right hand side, it is what? It is +2. So you're saying which reaction is correct? Which statement is correct? Lead is both being oxidized and reduced. Yes, it went from 0 to +2. It went from +4 to +2, right? So from 0 to +2, it's oxidized. And from +4 to +2, it's being reduced. And so, yes, it is. Achha, my question to you guys is this a disproportionation reaction? Is this a disproportionation reaction? Be quick, shabash. Is this a disproportionation reaction? Why, Yahya? Yahya is saying no. Is everybody also agreeing with Yahya? Jaldi karein yaar, mehman baithe hue hain, shabash. Everybody is agreeing with me. Not the same species. Awesome, Yahya. Awesome. So my concepts, I'm glad that I've taught you guys proper concept. Awesome, Noor. Awesome, Yahya. It's not the same species. This is, in fact, what name did I use for this? Although it's not a part of your course, but what name did I use for this? Remember the live class? What name did I use for this? Shabash. Yes, I call this reverse disproportionation. And the reason why it's called reverse disproportionation is because if you look at it from right to left, if this was from right to left, then it would be disproportionate because this plus 2 would be both be going into plus 4 and 0. So this is in fact reverse disproportionation, not disproportionation. Right? But it's not disproportionation. Please. So concepts, important. Acha, this is 5 and that's 5. We've like seen it a billion times. D is the correct. But again, obviously I'm not just gonna write 5 and 5. I'll break it down for you. So MnO4 minus is going into Mn2 plus. I'm just teaching you guys, KR, you could even do it in a GIF of a second. Fe2 plus is going into Fe3 plus. Balance the electrons. Fe2 plus goes into Fe3 plus by losing an electron. Write the electron on the more positive side. MnO4, this is Mn, this is Nm. Balance out the O's with H2O's plus 4 H2O's. Balance out the H's with the hydrogen ions. 4 times 2, 8 H's. Add the 8 hydrogen ions here. In total, you have a plus 7 positive charge here and you have a plus 2 positive charge here. How do I make plus 7 equal to plus 2? By adding 5 electrons. So I'm going to add 5 electrons here. Again, electrons gained must be equal to electrons lost. So this should be multiplied by 5. And I don't even have to write the full equation. If you want, you could add the left and right hand side. But I don't want to do that because I don't want to waste my time. I know this 5 is being multiplied by Fe2 plus. This 5 is being multiplied with Fe3 plus. And that's what the examiner is telling me. If this Y, oh, what? I think I did it wrong. Wait, Y is 5. Sorry, my bad. This is 5. Y is 5. My bad. Sorry. Just bati ho gaya. So C is the correct option. Y is 5. I just looked at this 5. I thought Fe2 plus is X, but it's not. Itna just bati bhi nahi hona. Don't be like Sir Suleiman. Don't be this just bati. But this 5 is with Fe2 plus and this 5 is with Fe3 plus. You can add these equations together if you want. Sir, itna repetitive ho raha hai. See, it's still fun but repetitive. That's what I said to you guys. A levels is a piece. It's a joke. It's a joke. If you study conceptually, it'll be a joke for you. It is a joke for me and it's always been a joke for me. So should it be for you. This is what we've calculated it. It's plus 5. If you don't know how to calculate it, watch the recordings and you could watch the above class. This again is plus 5. This is minus 1. ClO4 is something new, but we've also done that. Chlorate ion. Let's see what chlorate is here. This is X. O is always minus 2. Minus 2 times 4. Add them together. Overall oxidation state is minus 1. X minus 8 equals minus 1. X equals plus 7. So here it's plus 7. Great stuff. Plus 5 to plus 7 and minus 1. Is this a disproportionation reaction? Absolutely it is. See, plus 5 say it's also being oxidized and it's also being reduced. This is not disproportionate. It is redox, but it's not disproportionation because the same species is not being oxidized and reduced, right? Again, here Cl2 is 0. This is minus 1 and ClO3 it's plus 5. Done. So this is also a disproportionation reaction. Why? Because 0 to minus 1 reduced, 0 to plus 5 oxidized. So the element in the single species is both being oxidized and reduced. Yeah, so this is also disproportionation. Thak. And 1 is not disproportionation. So which statement about this equation? Equation 1 describes the formation of a compound used to kill bacteria in drinking water. I've not taught this. Again, chapter number 4 may you'll learn this towards the end, but it's actually the ClO minus ion which is responsible to kill bacteria. Please, the chlorate ion. That's the, if you bubble chlorine in a swimming pool, this is what kills bacteria. The chlorate ion forms. I think I've taught it to you guys. I think I have. If I'm not wrong, I think I've taught it to you guys in redox. If I'm not wrong, I think I have. When I was teaching you guys how to calculate the oxidation number of ClO minus, ClO3 minus, ClO4 minus, I think I have. But if I have not, it's the ClO minus ion which kills bacteria. I'll teach it in chapter 4 again. Equation 1 does not represent a redox reaction. It is a redox reaction. It's not just a disproportionation reaction. And so A is also wrong, B is also wrong because it's the ClO minus. The formation of a compound which kill bacteria. KCl does not kill bacteria. It's ClO minus ion. So it should be like KClO to kill bacteria. Equation 2 describes the formation of potassium chlorate 4. Absolutely incorrect. Why? Because what is the name for this chlorate ion? This is called what? Potassium. Shabash, potassium chlorate what? 4? Chlorate 7. The oxidation number is 7, not 4. So potassium chlorate 4, absolutely incorrect. 2 and 3 both represent disproportionation. Absolutely they do. Khatam. 2024 set over. We're done. Any questions, guys?